Hi, welcome back to the Aquifer. I'm Ted Bennett. In this video, I'm going to show you how varying your pump speed using a variable speed drive can have some impacts upon the efficiency of your pumps, and specifically depending upon the shape of your system curve. And so what I've got here is I've got a pretty simple pipe network put together, and you've seen this uh, pipe system before if you've watched some of my other videos. And what I've done is I've gone ahead and just added a third pump here. And the reason for the third pump is I'm going to use each one of these pumps to demonstrate the system running at different speeds. So the pumps are going to be identical. We're just going to run them at different speeds. And so what I want to do here first is I want to show you how to change the pump speed. This is pretty straightforward. I'm just clicking over here. And I think what I'm going to do is I'm going to make 1000 RPM my full speed setup for this situation. And so what we've got is pump number one running at 1000 RPMs delivers roughly 390 gallons per minute, and that gives us an efficiency with this unit of 61%, and it's really good. We're at like 92% of best efficiency. This is a good selection. Something always to be aware of, and we'll watch this as we're doing variable speed pumping, is we got to watch our velocity here. A lot of the manufacturers of pumps and variable speed drives will advertise that you want to match your incoming flow with your pump, and that is a reasonable operational scheme. But you have to be careful because you want to make sure that you're getting sort of good velocities through these pipes. If you're going to constantly run slow, as we'll see perhaps in our slower speed here, we'll watch our velocities drop as our flows drop. So what I'm going to do is I'm actually using the design case setup here that I haven't used yet in one of my demonstrations. But basically what I do is I have this set up so that pump number two now is running at 900 RPM. And so we dropped our flow and we lost some efficiency, but not bad. We went from 61 here, and we're down to 59. So pretty reasonable, not a lot of change there. Best efficiency went down a little bit. We're at 78 versus the 92 we had before. But if we turn the pump down to 750 RPM, our efficiency now really has started to drop at like 48%, and now we're only at 41% of our best efficiency. And as I mentioned, here we go, our velocity has started to become too low here. We're less than 2 feet per second in this 8-inch pipe. So there's a good chance that we could see some siltation in this pipe because we're not going to get a very good cleansing velocity. So like what I mentioned before, and before I switch back over to a system curve, so I want you to see that this is a very short force main. It's only 300 feet, so we have very little head loss associated with the friction in the pipe. So switching back to our system curve, this is the same information that we had before. These are our three pumps running at 3 different speeds. And so what I've done is I've gone ahead and just plotted those operating points, all 3 of them, and I've overlaid this with the performance curves for our 3 different speeds here: 1000 RPM, 900 RPM, and 750 RPM. If you're interested in learning how to read the pump curves, we've done a demo on the YouTube channel of that before, so that's something that you might wish to take a look at if this is some new information to you. So what we're seeing here are the ISO lines for pump efficiency in green. So as you can see, as you move up closer and closer to this best efficiency point, which is probably somewhere right in here, you can see your efficiency lines getting better, and then as you move away, it obviously goes down. So what I've done here is I've gone ahead and I've demonstrated, this is our preferred operating range from our pump manufacturer, and this is something like ranging from 70% of best efficiency point up to about 120% of best efficiency point, which is something similar to what you're going to see. So like I had shown in the pipe flow model, we're roughly 61% efficient here. This is good. We're landing in the preferred operating range. We're right here at a really good spot right in the middle of all that. When we slowed it down to 900 RPM, you can see we lost some efficiency. We're somewhere between 58 and 60. I think we were at 59%. Again, still in the preferred operating range. But here's the challenging one. When you see that we've turned it down to 750 RPM, now we're starting to drop out of the preferred operating range. And one thing I want to point out is, as I mentioned before, this is almost all static head. We have very little frictional head in this very short force main. And these are the ones that you got to be careful about, because this is a situation where the shape of your curve is very flat, and so it's easy to drop right out of the preferred operating range, very easily by turning the pumps down. Sometimes you'll see curves that have a real steep shape, and it's not as concerning. But this is the situation where this could happen, and we've actually almost dropped out of the allowable operating range. If you're designing pumps, you really want to stay within the ISO lines that the manufacturer is giving you for efficiency. If you start to get out beyond this, you're going to have some additional wearing. You're going to have some noise. It's something that you're definitely going to probably be unhappy with in the long run. So that's what I wanted to demonstrate here. Is you got to watch your speeds. If you're running down here, we're also having a velocity issue in our force main. Sure, we're going to run out our run times. We're going to run a long time, but we're going to run a long time at not a very nice point. In this particular situation, maybe turning down to like 900 is some sort of happy medium, because we still stay in a pretty good operating situation, but we don't drop so far down that we're sort of having adverse impacts upon our pump. So I hope you found that to be interesting, and I hope that helps you with your design projects in pumping. And look forward to more videos from me here, and I will soon be sharing more. So thank you and have a great day.